Good afternoon, Robert Scribbler. It is August 30th, 2018. Thank you for joining me for another climate change and clean energy video blog. Now, for this segment, I am going to talk about a heat wave that is settling into the U.S. East and that is today apparently producing some very high temperatures. At least we're starting to get some early indication that both temperatures and heat index are very high for the mid-Atlantic and the Northeast. And I'm going to talk about that now. Of course, these are based on GFS model observations, so these will not be final observations for the U.S. East Coast, but they do provide an indicator that it's pretty miserable out there. And I can attest to it because I'm living here in Gaithersburg, Maryland, and it's very hot, and moisture levels are rather high as well. And this combined heat and high moisture levels combined with high temperatures are making it feel very miserable. But before I get into that, I'd just like to note that atmospheric water vapor as measured by dew points has been very high across the U.S. East, and so I'd just like to point out a new record for Hartford in Connecticut, and the statement from a weather observer, Ryan Hanrahan, notes that this is pretty ridiculous. The amount of time we spent with a dew point greater than 70 degrees Fahrenheit this year is outrageous. More than 6 hours just blowing away the previous records for the most humid summer. And so Hartford and Connecticut has exceeded its record for the most humid summer since record keeping began, according to this report by Ryan Hanrahan. And it's worth noting that there are a number of factors involved with this, one of them being very warm, much warmer than normal sea surface temperatures off the U.S. Northeast coast. And as well as just a general, much warmer than normal sea surface environment for the Gulf of Mexico and the Atlantic Ocean near the U.S. East, Southeast, and Northeast, and a high-pressure system that has tended to circulate these much warmer than normal waters and the evaporation coming off those much warmer than normal waters into the U.S. East Coast. Now, these higher humidity levels, higher dew points, increase what is known as the heat index or the misery index, is how bad the heat feels. Because higher humidity reduces the ability of the skin to evaporate and cool. Higher moisture levels just saturate the skin with moisture, and if it's hot moisture, it prevents the skin from carrying heat away from the body. And not only can that be miserable, but that can, as conditions worsen, that can be dangerous in the sense that it increases the risk of heat injury, and the most extreme cases, potential for loss of life due to heat injury. Now, as it relates to human-caused climate change increases atmospheric water vapor levels. It increases the temperature, and in particular, the U.S. East is a more vulnerable region due to prevailing dynamics. The U.S. East is surrounded on two sides by warming oceans, and high pressure systems and weather systems tend to circulate evaporation off those warmer than normal waters, as well as just overall global warming, increasing temperatures. It increases the risk of heat injury for the U.S. East as global temperatures rise. And it's one of the regions of the world, particularly in the middle latitudes, where if fossil fuel burning continues, you start to experience wet bulb temperatures closer to 35 degrees C, which is the human limit for for habitability. So if it feels hot out there, it's because it is, and it's because the heat is increasing, as well as atmospheric water vapor. And with 1 to 1.2 degrees Celsius warming on a global scale, we're starting to feel more intensely some of the effects. Of course, these are earlier impacts, and so the impacts that we feel right now are rather mild. So looking, I'm sorry, I want to say rather mild in comparison to what they can be if we keep burning fossil fuels. So just looking at today's weather map, it's worth noting that initial GFS observations indicate the potential for temperatures above 100 degrees Fahrenheit in central and eastern Virginia. Now, of course, I'm just noting you can kind of take this a little bit with a grain of salt, because these are not final indicators. We haven't had final measures, but it is an indicator that it is really high out there, likely at the very least in the upper 90s and possibly above the century mark in central Virginia. I'd just like to also note the heat index is approaching 107 degrees in central Virginia, which is pretty insane if that's the case. If we're getting heat indexes close to 110 degrees Fahrenheit in central Virginia, just as a comparison, heat indexes in the Sahara Desert are presently comparable. So, and even during peak heating times, comparable. So it feels, according to this GFS model indicator, about as bad in central and eastern Virginia as it feels in the Sahara Desert. So some pretty extreme heat indexes indicated in this GFS model. I'd just also like to note that heat indexes in the Northeast, as well as temperatures, are very, very hot, temperatures ranging into the upper 80s and likely into the 90s for some locations. I'm going to go ahead and just zoom in here and take a closer look. So yes, indications for the 90s in New Jersey and upper 80s to possibly lower 90s in Connecticut and parts of Massachusetts, with the heat index also quite high. So very miserable conditions for the U.S. East, but also in the context of some new records for record high humidity occurring in conjunction with presently very, very warm temperatures and the potential for record temperatures as a ridge zone settles in across the U.S. East over the coming days. So just a climate change index to present, climate change indicators to present high heat indexes and very high temperatures based on initial GFS model observations for today. Thank you for joining me, and I'll be chatting with you soon.